Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics, an introduction. In the previous video, we talked about the properties of the expectation operator as the first ingredient for us to jump into the statistical properties of OLS. In this video, we're going to look at the second ingredient, and that is the properties of the variance operator. The variance operator tells us basically how much randomness survives after taking the expectation, or in simpler terms, how much do things fluctuate around their expectation. Let's see firstly, before we move to the actual properties, what does the variance measure per se? The definition of the variance, mathematically speaking, now that we've given the English wording for it, is the variance of x is equal to the expectation of x minus the expectation of x, all of it squared. Okay? So remember we said how much things fluctuate around the expectation, and this formula is showing for that as well. If we go back to our example on the fair coin that had one side number written 2 and on the other side had a written number 8, we had both 2 and 8 appear with probability 1/2, since it was a fair coin. We found that the expectation of this variable was 5. We did the computations together. So let's see what the variance is in this case by applying the formula for the definition of the variance. And this is going to be simply 1/2 of 2 minus 5 all squared plus 1/2 8 minus 5 all squared. I have done the computations for you, so you don't need to know that, but this number is going to be 9. Now, look very carefully. You might be asking, well, Lydia, I don't really see the formula being applied in here. Well, remember, we have 2 possible options. So this formula is going to have to be computed 2 times for all of the values that we have seen about the x. And each of these cases is going to happen with a probability 1/2. So for the first case, with a probability 1/2, we're seeing a number 2 that deviates from the mean 5 by 2 minus 5. And then we're squaring them. Then we're doing exactly the same thing, but probability 1/2 of me observing the 8 side of the coin, deviation from the mean 5, and then all squared. This variance is basically a measure of the spread. Now that we've given the definition of the formula and also the intuition behind the variance operator, let's move to the properties of the variance operator. The first property is that the variance of a constant is 0. If you think about it, if you have a constant, you're always going to see that number, meaning there's no variation in the values that you see. So constants do not vary. The second property, and that relates to something that is very particular about the variance operator. The variance operator is quadratic. So for the expectation operator, we said that it is linear, and we used that linear property when we saw the properties of the expectation operator. However, the variance operator is quadratic, so let's see very quickly how exactly that translates. That means if I have the variance of a times x, where a is the constant, then this is simply a squared times the variance of x. For example, let's say you have a number that it's, or an information that tells you that, well, the variance of x is 4, and let's say I've given you a constant of 3. That means that if you ever computed the variance of 3x, that should just give you 3 squared times 4, which is the variance of x, which means you should get 36. So scaling a variable scales the variance quadratically. Let's move to the next property, where we're going to see one little assumption being made. So if x and y are independent, then the variance between the variance of x plus y is going to be literally the variance of x plus the variance of y, okay? However, and this is probably what you should be remembering more as the generic formula for this part of the property, is that if not independent, then the variance of the sum, x plus y, is actually equal to the variance of x plus the variance of y plus 2 times the covariance of x and y, okay? And in here, we haven't really introduced the covariance operator, but the covariance operator also has its own properties, and we do have a formula for the covariance as well, but we'll talk about it in a separate video. Now, keep in mind, this formula will become very crucial later on. Before we move to the next point and to the conclusion of this video, I would also like to bring to your attention one little element. If instead I have the variance of x minus y, the only element where you will see a change in the sign is actually only before the covariance operator. The variance operator, as we said, it's a quadratic operator, which means that this minus in here, it's equivalent to basically you having a plus times minus 1 times y. The minus 1 being the constant in front of the y would come in front of the variance operator as minus 1 squared. This is why in here you don't see a change in the sign in front of the variance of the y. However, the covariance operator, on the other hand, is linear, and that's why the minus does show in there. If you had the more generic version of this formula, this would look as ax plus by being equal to a square variance. So even with a minus here, variance of x plus b square variance of y plus minus 2ab covariance of xy. So you can understand a little bit more clearly why the minus of that minus 1 would show. Before we conclude the video, I'm also going to show you the variance of sample averages and the rule behind it. The idea is that for independent observations, we're going to find that the variance of the average of x is ultimately equal to the variance of x divided by n. This is also a little bit of the intuition why averaging reduces noise and a key idea behind sampling distributions. And standard errors. I will not be giving the actual proof in this video because there will be a separate video where we show both the expectation of the x bar and the variance of the x bar. However, this should be enough for you to have an idea of what the variance operator entails and also how the variance describes the long-run spread. So to summarize, we've seen so far two key ingredients: the expectation operator that described the long-run average, the variance, the long-run spread. And with these two tools, now you should be ready to understand and get a better view of the maths behind the statistical properties of OLS. I'll see you in the next video.